Welcome back to my YouTube channel, Massa Tutorials. Please do all to subscribe to this channel. Alright, so now we'll be talking of Math 102. That's Analytic Geometry and what? Calculus. Analytic Geometry and Calculus. So now we start with a coordinate geometry. Coordinate geometry. Coordinate geometry. Coordinate geometry. Coordinate geometry. So we start with a straight line. A straight line. What's a straight line? Is a straight line. So a straight line is when what 2 points are joined by a straight edge. It's when 2 points are joined by what? A straight edge. Then that means we get what? A straight what? Line, right? So when 2 points are joined together, when 2 points are joined together by a straight edge or a rule, then we get what? A straight line. We get a straight line. So if I have a point, this point in the OXY plane, that's y-axis, then my negative y-axis. So let's see the point here, that's somewhere here. That's the first quadrant, right? So I have this point, let's say point A. Then I have another point in the OXY plane. So let's see the second quadrant, right? So that's point B. So I have my X, then Y, then here too I have, let's see the point AB. So when I join this point together with a straight edge, I get what? A straight line. I get a straight line. So this one too is a two-dimensional plane. A two-dimensional plane. It's a two-dimensional plane. So we get what? A straight edge. We get a straight line, sorry. We get a straight line. So when 2 points are joined together, we get what? A straight line. So let's see. Let me read something for you to hear. Listen very carefully. He said, also, points on the line can be identified with what? Real numbers. With real numbers. Real numbers. Also, points on the line can be identified with real numbers to form the coordinate line. To form the coordinate line. To form the coordinate line. I believe you all know real numbers. Real numbers, when you talk of real numbers, you have rational numbers, irrational numbers, natural numbers. They are all available for real numbers, right? So, with real numbers to form the coordinate line. Similarly, points on a plane can be identified with ordered pairs. That's a point, ordered pairs. So if I have 2, 5, this is an ordered pair for a point. This one can be located in the first quadrant of the OXY plane. The OXY plane, so 2, 5, which means this one is the X coordinate and this one is the Y coordinate. They are all positive X and Y coordinates. So we can locate that in the first quadrant. First quadrant. Alright. So similarly, points on a plane can be identified with ordered pairs of numbers to form the Cartesian plane. To form the Cartesian plane. So when we talk of the Cartesian plane, we are talking of what? The two-dimensional plane. That's the 2D. The two-dimensional plane, which involves what? The y-axis, that's the vertical axis, then the horizontal axis. Then we have our origin located there. So y-axis, negative y-axis, negative x-axis, then our x-axis. So known as what? The Cartesian plane. The Cartesian plane. That's the OXY plane. The OXY plane. Alright. So to form the Cartesian plane, full stop. For instance, any point P in the coordinate plane can be located by a unique ordered pair of numbers AB. Again, for instance, any point P in a coordinate plane or in a Cartesian plane can be located by a unique ordered pair of numbers AB. By a unique ordered pair of what? Numbers AB. Alright, so if you have any point P on the Cartesian plane or on the OXY plane, you can locate this point with what? Different numbers, different unique numbers. So you can locate point P as -3, 5, and also you can locate another point P as 5, -3. They are different. They are different. Here, it moves to the negative x-axis. Then here moves to the what? The positive y-axis. So it can be located in the what? In the third quadrant of the OXY plane. Let's move on. The first number A is referred to as the x-coordinates of P, and the second number B is also referred to as what? The y-coordinates of P. So now, as I said earlier on here, let's denote here as A, then let's denote here as what? B. So this first number 2, referred to as what? A. It can be located in the what? In the x coordinates. The x coordinates. Always the first number in the ordered pair, or always the first number for the points can be located in the what? In the x coordinates. Then the second number after the first number, that's 5. Then represent it as what? B can be located in the what? In the y coordinates. Mind you, the y coordinates we have what? The positive y coordinates, then we have what? The negative y coordinates. It's the same thing that applies to the what? To the x-axis. We have the positive x-axis, then we have the negative x-axis. Alright, so that's the introduction to what? Coordinate geometry. That's coordinate geometry 1. We are starting with what? Straight line. So, Math 102 Analytic Geometry and Calculus, we'll be looking at what? Coordinate geometry 1, which is the straight line. Then also we'll be looking at what? Coordinate geometry 2, which involves what? Circles. We will not be looking at the 3, that's a parabola. I'm sure that's calculus. It will send us towards calculus. And we'll be drawing the quadratics then. What happened? Alright, so that's the introduction to coordinate geometry. So all what I am saying is a straight line, 2 points. If you have 2 points, then you join them with a straight edge, then that means a straight line is what? Is formed. A straight line is formed. Then when you come to the OXY plane, we have the first quadrant, second, third, then the fourth quadrant. First, second, third, and the fourth quadrant. So every point is unique. Every point in the OXY plane is unique. You can get a point as in point R, which is -12. Then 3 on 2. This one. Mind you, I said what? They are all real numbers. So this one, -12, is a real number. It's a real number, which is what? A rational number. 3 on 2 is a real number, also a rational number. So they are all real numbers. And you know that rational numbers too are a subset of these real numbers, right? Okay. So when you draw the Venn diagram for set of numbers, you will see that. Alright. Okay, so now let's move on to our next subtopic, which is formula for the distance. Formula for the distance. We are moving on to our next subtopic. Formula for the distance. So our next subtopic, which is formula for the distance. For the distance D, A, B between 2 points. Between 2 points A, x1, then B, y1. And B, x2, then y2. So this is our next subtopic. So formula for the distance DAB between 2 points point A, x1, y1, and point B, x2, y2. So you can see the uniqueness of each point. So point A has what? X1, y1. Point B has what? X2, y2. So we assume that point A has this value, so this real numbers, x1, y1, then point B, x2, y2. So how can we find for the distance between these 2 points? How can we find for the distance between these 2 points? Now let's see how we can derive the distance formula. Derive the distance formula from the what? The OXY what? Plane. We are dealing with what? Two-dimensional plane. Two-dimensional plane. So let's see. So I have given point A, x1, y1, and point B, x2, y2. The distance between A and B, the distance between A and B, written as that is calculated as shown in the diagram below. So given point A, x1, y1, and point B, x2, y2, the distance between A and B written as what? This. So if you have 2 lines or 2 edges written as that of this 2 points AB, we call it what? The distance of what? AB. The distance of what? AB is calculated as shown in the diagram below. So another name for distance, we can call it what? Modulus. We can also call it what? The length. We can also call it what? The magnitude. Right. So distance, modulus, magnitude, and length. Alright. So let's draw our OXY plane. So let's assume only positive y-axis, then positive x-axis. So here, so let's draw something as this. We have something as this. So here, we know here to be y1, then here to be what? y2. Then here, we know it as x1, then here, we assume to be what? x2. Now, for the positive x-axis, we start with what? The smaller number. So when it's moving, it moves as what? As a bigger number, right? So when it's moving, so we can see that this x1 is less than what? x2. And this x2 is greater than what? x1. Likewise, when we come to the y-axis, when it is moving upwards, then that means what? The y values are what? Increasing, right? So we have y1, then it moves to what? y2, then y3, then y4. It moves as that. So it means that y1 is less than what? y2. So that means that y2 will definitely be greater than what? y1. So now, let's see. If you have point A, we can see that point A, it has what? x1 value, then what? y1 value. So as in point A is x1, y1. Then we have this, point C, that's x2 value, then it maps to the y-axis, which is what? y1. Then we have point B, which is what? x2 value, then it maps to what? To the y2 value in the y-axis, as in that. So we draw what? We draw a right-angled triangle. A right-angled triangle consists, or it contains what? 90 what? Degrees. That's a right-angled triangle. A right-angled triangle. So now, we can find for the distance. The distance between A and C, right? If you want to find for the distance between A and C, what is that? On the x-axis, right? We get what? We have to subtract this x1 from what? X to y. Because this x1 is smaller than what? X2. So we can do that. Right. So I can say that the distance, let me write it here, which is x2 minus what? X1. So I've placed in that. X2 minus x1. Likewise, when you come to the y-axis, we have that. You can subtract y1 from what? Y2 easily, because y1 is less than what? Y2. So I have y2 minus what? Y1. Y2 minus what? Y1. So we have it as that. So we are looking for, or we are interested in finding for the distance from A to what? B. We are interested in finding the distance from A to what? B. So let me place what? D here. Right. So if you want to find for the distance from A to B, what will you do? Because this is a right-angled triangle, and you want to find for the distance of this, and you know that from Pythagoras Theorem, we can deduce that this A, this D, or this length, or this side is the hypotenuse. That's the longest side. Why? Because this 90 is facing, or this 90 is opposite to this side. So if the 90 degrees is opposite to this side, then that means this side is the what? Is the hypotenuse. Right? So you can use Pythagoras Theorem to find for what? The distance. Very, very simple. You can use Pythagoras Theorem to find for the distance. We had the distance of A and what? C, between A and C, which is the x-axis. Then also the distance of B and what? C, which is what? The y-axis. Why? Because we subtracted x1 from x2, so you get that. The difference, right? Then here too, the same thing happens to that. So watch it very carefully. So now, we move. So let me clean this place, then let's continue, right? Let me clean this place. Then let's derive the formulae for that, for the distance between 2 points, or the distance of AB. So let's see. It says that, let me read something here. Let us consider the right-angled triangle ABC. We are considering this right-angled triangle ABC as shown below here, as shown on the board. So by using what? The Pythagoras theorem. So by using the Pythagoras theorem, by using the Pythagoras theorem, by using the Pythagoras theorem, and you know that Pythagoras theorem states that what? The square on the hypotenuse. You know that Pythagoras theorem states that the square on the hypotenuse must be equal to sum of the lengths sum of the lengths of the squares on the other two sides. So Pythagoras is a great mathematician. That's a Greek mathematician. He's also a philosopher. He states that the square on the hypotenuse of every right-angled triangle must be equal to what? The sum of the lengths of the squares on the other what? Two sides. So the sum, we add the length of that squares on the other what? Two sides. Alright, so the square of this, then the square of that. Then we add them, right? It must be equal to this squared. So we can state that we are using this, then we state that the length of AB all squared, right, which is the hypotenuse, must be equal to the length of AC all squared, then plus the length of BC all squared, right? So the length of AB all squared, which is what? We denote it as what? D squared, right? We denote it as D. And D, we know that AB is D. Then we have our square. So I will get what? D squared, which is equal to the length of AC. We know that is what? X2 minus X1, right? Then all what? Squared. Then plus BC is what? Y2 minus Y1 all what? Squared. So we are finding for D, or we are making D the subject. What do we have to do? We take the square root on what? Both sides of the what? Equation. So I have square root of D squared must be equal to the square root of what? X2 minus X1 all squared plus Y2 minus Y1 all squared. So this square removes, or it takes out the square root. So I have D, which must be equal to what? The square root of what? X2 minus X1 all squared plus what? Y2 minus Y1 all squared. Now we all know that when square root is coming, it brings what? Plus or minus, right? But here we are not interested in the what? In the negative, because of the distance we are finding. We are interested in what? The positive what? Values. Do you understand that? Alright. So now here, this is the formula for finding what? The distance between what? 2 points. The distance between 2 points. So we can say that D of what? AB. That is distance of AB, which must be equal to what? Square root of X2 minus X1 all squared plus what? Y2 minus Y1 all squared. So that's how we find for what? The distance. That's the derivation, or how to derive the distance from what? The OXY plane, the two-dimensional plane of 2 points. We have 3 points. That's the three-dimensional plane. That one is different. Now we are concentrating on what? The two-dimensional plane. How to derive the point, the distance between what? The points. And there's the formula for finding for the distance between the points. Alright, so watch it very carefully. Alright, we'll end here. We will end our tutorials here. We'll meet on our next video to solve more questions on the distance of 2 points, or how to find for the distance of 2 points. Thanks for subscribing, and please do all to subscribe to what? Massa Tutorials. We've started with what? Analytic geometry and calculus, math 102. Don't forget to subscribe. Massa Tutorials. And if you have any question, you can drop it at the comment section, so that when I get time, I'll read it, then I'll get back to you. Alright, Massa Tutorials made easy, right?
All right. Thank you. Then have a nice day. Bye-bye.